Today, we're going to walk through a demo around personal loans data. The data set we have contains 1.5 billion individual loans. Each record, each loan contains data points about the borrower, such as their debt-to-income ratio, their employment status, etc., as well as characteristics of the loans themselves, such as the installment amount, the outstanding principal, and so forth. In addition to the fields in the data set, I've also used Zoom Data's derived fields functionality to add certain additional contextual information. For example, based on the loan amount, I've added a loan size field that essentially buckets the loan into three main categories of small, medium, and large. And we'll see as part of the demo how I can use these derived fields for more meaningful insights. So now let's begin exploring this data set and try to find some cool insights. So the first question that I have as an analyst is I want to find a distribution of the loans by the risk category associated with each of them. And typically, a good way to see a distribution of a data set is by looking at a visualization such as a donut or a bar chart or a pie chart. So as I pull this up, I can see that my loan grades A through D represent a large chunk of the loans, and loans grades A through D also happen to represent the relatively lower risk grades. The highest risk grades are F and G, and those represent much smaller slices of the overall portfolio. So now I have a good sense of how my portfolio lies and what's the distribution of that. With that, my next question is around the loan status and how the various loans fall into the various possible loan statuses. For that, I would like to take a look at a more conventional pivot table view. And as I pull that up, I see certain KPIs distributed by loan status. The first thing I want to do is reorganize them in a bit more meaningful fashion. So I just simply drag and drop and move things around. And a couple of key things stand out immediately. First of all, I can see that in terms of the number of loans, the loans that are current happen to represent about 94% of the overall portfolio. But if I look at the outstanding principal, the current loans actually represent 98% of the portfolio. Also, I can quickly see that in terms of outstanding principal as a ratio of the total loan amount, we stand at about 88%, which means that basically most of these loans still need to be paid down significantly. But even within that, I can see that, for example, in the late by 31 to 120 day bucket, the percent outstanding stands much higher than any other loan status. So those are interesting insights that I'm quickly able to glean by looking at this table. As I continue down this path of analysis, my next question then is around a distribution of interest rates across the entire data set. And usually a good way to look at a distribution is using something like a histogram. So as I pull that up, I can see the distribution of all 1.5 billion loans across the various interest rates. And the first thing that strikes me is that this distribution is not the perfect bell curve. It's in fact weighed more towards the left. And so the highest number of loans that I have fall into this 12 to 14% interest rate bucket. But at the same time, the interest rates at the higher end of the spectrum contain only a very small number of loans, which if I actually correlate to the pie chart makes sense because I have a much smaller slice of loans that are the high risk kind, and the high risk loans typically are the ones also that have the highest interest rates. So it stands to reason that my distribution based on interest rates is in fact skewed to the left. But as an analyst, I always have the option to look at a distribution of a different numeric field. For example, let's say the debt to income ratio. And here I see a much more normalized bell curve type distribution. And so while this is happening, I can reorganize some of my content. Continuing down this path of analysis, my next question then is about trends over time. And so I want to see how loan amounts and outstanding principals have been doing over time. And so for that, I bring in a line and bar chart. And while that's building up, in fact, it came back, I can see that the number of loans on the Y1 axis and the outstanding principal on Y2, even though the amounts are different, but the general overall trend seems to be the same. They seem to be going up and going down in lockstep with each other, which is interesting. But I wonder what happens if I, instead of looking at the outstanding principal, I look at the outstanding principal as a percent of the overall loan amount, for which I have created this calculation. And so as I switched that, I actually see quite a different trend. And this time, what I see is that over the past 6 months, 6 to 7 months, the percent outstanding has in fact been steadily on an uptick, which is something that would not have been readily evident had I not been able to create that calculation and trend it using Zoom Data's intuitive functionality. So my final set of thoughts are around delinquency and what prompts people to be delinquent on their loans. And I want to do some analysis around that. So for that, I can bring up a heat map. And this gives me some indication of propensity for people to default on their loans based on certain categories or criteria. So my first take at this looks at home ownership and employment length as potential reasons or potential factors contributing to default. And I can see that there are certain hotspots. For example, people who have a mortgage and have been in their job for 10 plus years actually seem to have the highest propensity to default, which kind of seems counterintuitive, but at this point, this is what the data seems to be telling us. So out of curiosity, I want to figure out how that varies based on looking at just the highest risk loans. So I select my F loans and filter all. So now all of my charts are being updated based on just those F loans. And as you can see, the debt to income ratio distribution is changing as well as the trends are changing. So as this data comes back, I can see that my default propensity heat map has in fact changed when I focus only on the F loans. And now people who own their homes and have been in their employment for 4 years seems to be a hotspot in terms of propensity to default. So the whole dynamic has changed when I've zoomed in only on a specific grade of loans. My next question then is, how has that happened over the last few months as opposed to the entire time frame? Because I think there might be some recency things going on. So I can simply move my time bar to focus on the most recent time period. And I can see that I have the same hotspots, but the intensity of the hotspots has increased. The numbers associated with them have increased. At this point, I'm wondering if, in addition to time and home ownership and employment length, there might be some other factors at play. I have a hunch based on my knowledge of the data that maybe it's also in some way related to the size of the loan. And if you recall, when we constructed the data set, I added a derived field for loan size. So I want to zoom in on this hotspot based on that loan size attribute and see what that tells us. And as it turns out, it seems to me that that propensity to default seems to be skewed heavily towards the larger loans. So in fact, the loan size might be at play here. And so now I'm down to about 24,000 loans in this bucket of large loans for people that own their homes. So from a data set of about 1.5 billion, I've been able to zoom in on a pretty small cohort, about 24,000 loans that meet these specific criteria: high risk, large size, over the past month. And now I can drill down to the details, pull up all of the information related to these loans, and potentially take them into downstream applications by exporting this data and completing the analysis loop that way. So in summary, what you've seen in this demo is the ability of Zoom data to help produce extremely large data sets in a meaningful fashion without having to think about the questions that need to be asked up front, and to be able to do so in a very intuitive and easy to use fashion.